Continue with the object-oriented programming, OOP, in Python. And last time we talked about encapsulation. Encapsulation was the way that you put data and the functions together. Functions in a class are called methods. So methods and functions are put together, so it's easier to remember what functions are supposed to be acted upon what kind of data. And also, Python doesn't support it, but many other languages have private and public variables, so that you have different levels of security, which allows a big team of developers to make sure that they're not encroaching upon other people's private variables, and so that no certain side effects can occur. Right? Side effect was a big thing, right? If you modify something that's shared across many different places, then if a function modifies a variable that's used in many different places, then you end up having unexpected behaviors for the person coding this one part, because he doesn't know about the changes that's done in other parts of the function. So being able to have these distinction between public and private allows you to make sure that no side effects happen. Another thing, so another thing that we are going to do today would be, we'll talk about abstraction, polymorphism, and inheritance, okay? So let's talk about, let's make a new class. So class rectangle. I forgot to tell you this, but in Python, classes are supposed to start with a capital. Right? That's like a convention that Python programmers use. So it's easier to read. If you're instantiating a class to make an object, you can easily recognize it because the initial letter is a capital. Okay? So that's what we have. And for a rectangle, we'll just have 3 kinds of variables. So any class should have this init function, which is the first function that gets called in anytime it's instantiated. So we'll have init, and then we'll have width, and length, and color. Now I want to make the color as an optional variable, so I'm going to put color as black. And then don't forget the colon. So we put the colon. And we'll have self.width equals to width, self.length equals to length, self.color equals to color. Okay. So we do this, and we have, if I press enter, now we have a class rectangle. And you can say R1 is a rectangle. That has width of 3, length of 4, and we don't specify the color. We'll just say this. Oh, sorry. There is a there's a problem here. I forgot to put the self. So any method inside a class must start with a self. Okay. So let's move up arrow. Put the self here. Forgot about that. All right, so now let's run it with R1 equal to rectangle 3, 4. It did its job. And again, let me explain how methods are different from functions. For methods, the very first argument is always the thing that you instantiated itself. So when you instantiate this, and you name it as R1, what happens is that R1 goes inside this init function, taking the first argument. So even though you're supplying just 2 arguments, in fact, into this init function, 3 arguments are passed. R1 itself, the width of 3, and length of 4. Now, this last one was an optional parameter. We didn't provide it, so it will just get the default value of black. Okay? So that's what we have. And then I can certainly ask R1 of width, it'll tell me it's 3 and all that. Okay. Now, what are the things that you want to do with this? Well, let's say you want to implement a method that also gives you the area. Now, you don't want to have self.area. That's a bad idea. Why? Because if you change the width and length, either internally or by something from outside, then you want the area to be compatible with it, right? So you want the area not as a separate variable, but as a function. So what we do is we're going to say define area, and then it will, you always have to get the self in it, right? So pass the self into it. And then we're going to say, what is area? Area is self.width times self.length. And you're going to return the area. Okay. So since R1 itself is passed into this function, this method, it already has all the values. It knows the rectangle itself's its width and its length and its color passed on to it as the self. Okay. So self.width will have the information of the width, self.length will have the information of the length, and now all you have to do is to use the formula that base times height, or base width times length is the area of a rectangle, and it gives you back the area. Okay, so now let's instantiate this again. And now what you get is if you do R1.area, it knows about this. Okay. So what we've done is we have a database where if you want to know some extra information, it has these extra methods to calculate it for you. Okay. You don't have to make a separate function calculating the area, or you don't have to make another line calculating the area. So imagine that you're working in a company and this is like an inventory data. Like you have every product, the manufacturing company, manufacturing country, country of origin, country of assembly, the retail price, what's like the manufacturing price, all these things. Right? So you might have like tons of information for each product that you have in a company in your warehouse to be sold. And often you might want to calculate something like should we go on sale or not? Okay? And it might have to do with how many of these products are there, what's the difference between the actual price we got and what's the manufacturing price, and you might have had some meetings with the higher ups to come up with some complicated formula to determine what percentage of sale you should allow for this at a certain time. Now those kind of calculations should be automatic, right? Using some complicated formula. Not every coder needs to know about it. Only those people who are making the class, who participate in the meeting, would have understanding to modify or tweak it if needed. So you don't want other people to be more concerned about it, or you don't want other people to be changing that code. So what do? You put it in the data as a method, and now what you've done is you've abstracted that special function so that people using this class do not have to worry about it. Okay, so this is the concept of abstraction. So what is abstraction? Abstraction is that you do not need to worry about some complicated things that's hidden inside the class. It just does it for you. Okay? And actually, we've managed to do a lot of those things. So for example, we had the list, right? List is actually a class. How do we know? Because list, you have all kinds of methods, right? So lists have data, and then it has class. And we were able to put a bunch of numbers in the list, and we did just list.sort, and suddenly everything got sorted. But sorting is a very complicated thing to do in a computer. We learned two types, right? We learned the bubble sort, we learned the Q sort, quick sort, and those things are implemented inside the list class so that we don't have to worry about what kind of sort to use. That's abstraction. So once you have things that are like the functions that are easy to think for humans, easy to accept, like sorting is kind of obvious, right? But hard to implement. Just have it somebody to implement in the class. And now the methods will be abstracted away, and all you have to do is just sort, and it just executes it. So that's another aspect. Okay, so we talked about encapsulation and abstraction. The third property of this OOP is that there's something called polymorphism. And let me demonstrate by adding another method here. It'll be a little bit different. So this time we're going to do def __ add __ self, comma, other. Okay? And what it would do is we are going to do self dot width plus equals to other, and self dot length plus equals to other, and then we are going to return self. Okay. All right. So let's see. Let's instantiate R1 again. Anytime you modify the class, you have to instantiate it again, or the previous instantiation of the class doesn't have that method in it, so you can't have this new functionality. So we're going to instantiate rectangle 3, 4 as R1 again. And then what we're going to do is R1 plus 1. Okay, so it returned something, right? Now let's see what R1 dot width is. Let's see what R1 dot length is. Okay, what happened? What happened here? Yeah. Just say it, yeah. It increased by 1, right? And this is kind of cool because, see, this rectangle by itself wouldn't know how to work with numbers. For example, if I did R1 times 2, it would say unsupported operand types for rectangle and int. Because I didn't implement that, right? Numbers can be added, right? Yeah. And you can have lists, and you can multiply them. So, some operations are allowed, right? But you can extend some of the methods. So internally, what's happening is when you do 2 plus 3, 2 and 3 are both integer objects. And in the object 2, anytime Python sees a plus, what it does is it executes the add method inside the 2, and puts in the 2 and the 3 into that. Okay? And because that's how 5 is calculated in Python, if we want to have this addition to be defined for a rectangle and a number, we just have to implement that add to it, and now suddenly you can add rectangles and plus a number. Right? Now, how would you make the multiplication work? Do you have a guess? Yeah?
When I did mine,
Yeah.
it added to the width, but not the length.
Maybe you didn't do the second one. Yeah. Okay. All right, so you have define underscore mul. Mul is the multiplication. Mul is the default method that gets called when Python sees the multiplication. So if you can do self.other, self comma other, sorry, other, and then this time will be self.width times equals other, right? And self.length times equals other. Okay? And then we can return self. Now let's instantiate that again. So if we instantiate this, now we can do R1 times 2, which is going to make R1 increase by, R1 dot length and R1 dot width. We'll give you twice of these. Width will be double of 3, which is 6. Length will be double of 4, which is 8. So that's what happened. Now, I don't like how Python spits out this one. So this is the default behavior. If you ask what R1 is, it will just tell you it's some kind of a class that's instantiated. It's some kind of the object that's instantiated at this memory location. So instead of doing this, you can force Python to represent in a different way. So what you can do is you can go up, and then you can put def underscore representation. I'm suddenly not sure. Let's try it. Representation self. And what you want to do is you want to return an f string, which has curly brace self dot width, curly brace close, right? X self dot length, and then we'll put the color self dot color, okay, and then rectangle is what we're going to see. Okay, so if you do this and then instantiate R1. Now, now if you do R1 and enter, it actually returns that it's a 3x4 rectangle, which is it's a black rectangle. Okay? 3x4 black rectangle. Okay, so now it's much more reasonable. If I do R1 plus 1, it will say it's 4x5 black rectangle. If I do R1 times 2, now it's going to say it's 8x10 black rectangle, and you see that R1 has now been made bigger. Okay. So, so you can do something called operator overloading. That's what this is called. So this plus operator, which wasn't previously defined, we overloaded that operator so that it knows how to act on rectangles. We've overloaded the multiplication operator to behave differently. And also, we made a representation to be different. We've overwritten the standard, the usual representation that comes with the class by default. We changed that to this one, which is much easier to read. Yeah, so what I was trying to explain here is called polymorphism. What is polymorphism? It's that you can have the same method to work differently for different types of data. So the same function, multiplication or add, was acting differently when you acted upon a number. Right? If you acted upon two numbers, it's just two numbers added, right? And if you act on the rectangle, we have this new thing. You can also multiply numbers to a list and all these things. Right. So polymorphism means that you can conveniently act on different things. So, for example, let me demonstrate this in a different way. So let's say we have a list of different items. So here's 4, okay? And here's R1, the one that we just made, which is 8 by 10 black triangle. And let's say we have 5, 1 as a list. So we have totally different things. And we can do a for loop for item in the list L. Print. Oh. Print might be not working for R1. Okay, well, anyways, we can do item times 2. Oh, it did work. Okay, good. So when we did item times 2, what did it do? For a number, it just did the regular multiplication, right? And for a rectangle, it doubled the size of the rectangle in each direction. So area actually became 4 times, right? And then for list, it just repeated it twice. So it's doing completely different things for the same operation, and that was we were able to do this by using classes, and this is called polymorphism, and it's often very convenient. See, let's say again back to that inventory business. Let's say this time we have a database of customers, right? And different customers might have different status. Like this might be a silver member, this one could be gold member, this could be executive or platinum, whatever, right? And let's say if certain people needs to be upgraded in their status, okay? Now, you want the platinum, you don't have any more place to upgrade, so that should be stayed there. Maybe the silver should go to gold, and all these things could be there, right? Now, one way to program this would be just a bunch of if-then statements. If he's silver, promote him to gold. If he's something, and having that in the part of the code makes it hard to read. Instead of doing that, you have an update function, right? And you might have an update for different classes. So maybe gold member will have its own class, silver might have its own class, and different members, update will be simply this person, if it's not update, sorry, upgrade. If this person is upgraded because this is a silver class, return a gold class or something like that, okay? So having this polymorphism sometimes makes the code lot more human readable and logic friendly, easier to see what's going on. Okay, so that's polymorphism. Now the last thing about OOP is that you can also do inheritance. See, when coding becomes large, one of the big principles are don't repeat yourself. If you had the same kind of codes just copy and pasted all over the place, that's a very bad idea. One of the ways to reduce repeat repetition is to make a function. Okay, if you make a function, then that function can be called with slightly different things, so that allows people to have less repetition. Now, classes will often do a better job in reducing repetition by doing this thing called inheritance. Now, just to add a little bit, why is repetition a bad idea in your coding? That's because sometimes the customers who are asking you to make a program for them, sometimes what happens is that they want slight change. But then what happens is that they want this small change, and you realize, oh, that change has to change every implementation of this same thing in the code. Now, if that code is repeated in a bunch of places and you have to go back and change each one of them, that's a huge task, and sometimes you would forget to change one of them, and now the program won't do what it should be doing, and you might have terrible bugs. So it's more time consuming when you have to change things. So when you write big codes, it's always important that you have to reduce repetition. Okay, and inheritance is one good way to reduce repetition. So let me show you an example. So suppose you want a square. So class square. Now, what are squares? Well, these are like rectangles that have same width and height, right? So what we do is we're going to do rectangle. Square rectangle. Okay. So what's happening is that square now inherited everything that the rectangle has. Okay. We will still have to define an init function. We'll override the init function. And then if we have, so it'll have self, width, length, no, not width, but just the color, right? Color, and the default should be black. So we have this. And what is a square? Really, you don't have to reinvent the wheel. It's really just the rectangle itself with what? Same width and length, right? So what you're going to do is you're going to call the super with open and close. We'll call the super class. Okay, so square is a child class of the rectangle. It inherits everything that the rectangle already has. So you don't have to write all these things that you've written here. Okay? And then even the initiation, you don't have to. I mean, one way to do this would be, don't type this. Okay. One way to do this will be to say self.width is width, and self.length is length, and then self.color is color. And that could be one way to instantiate it, right? Just like how we did it here. The only difference from this init function and the new init function is, width. The width is being used for both width and length, so that it's a square. Right? But instead of doing this, what we're going to do is we're going to call the super, open and close parenthesis, and then we're going to execute the init function. Okay? With what? We're going to execute the init function with just self, width, and width. Just like that. And then it should work. Okay? So let's enter. Okay, now let's say S1 is square of just 6. Okay, what is S1? Uh-oh. Oh, just a minute. It's calling itself. I do that, oh, maybe I shouldn't be using self. I think that's what it is. Okay, so it's working. Okay. Yeah. So when you call the function, you shouldn't use self because for methods automatically the first part is populated. Okay, so don't do that. Right? Okay, great. So now you see that without having to reinvent the wheel for this new type of rectangle where the width and height, the length are the same, we just have S1 equals the square of 6, and it just gives you a rectangle which is 6 by 6. Okay, and then we can do the same exact thing. All the methods that the square, the rectangle had, we have the same thing. And we can add 1. You can multiply by 2. Sorry, that's not S1. 2. Yeah, so inheritance is very good, which means that, let's say, and actually this happens a lot when you're interacting with the database. See, customers want the database format to now include a new entry, right? And you want that entry to kind of change other things as well. And when you make a class that interacts with the database, they have to be aware of this new entry. So you have to like go there and change everything. If you have, say, rectangle and square implemented in separate ways, where basically it's doing the same thing, now you have a problem. Right? The problem is that you have to go to rectangle and square and change the code separately. That's more wasteful, and debugging can be very hard. So this inheritance allows you to save yourself from repetition. Now, however, I don't like this one thing. It says 6 by 6 black rectangle. It's not a rectangle, it's a square. I want it to be square, so what should we do? Well, how did we make the black rectangle appear before? What was the implementation? Representation, right? Yeah. So what you need to do is you have to go back down to the square implementation and just overwrite the representation now, just for the square. So let's do this. Let's copy. Oh, there was something here. Okay. Let me just go up arrow until we get the until we get this return def. So we're just going to copy this and then go down arrow until we hit the square. And then what we're going to do is we're going to implement the new. Make sure the indentation is correct, because if you paste, the indentation gets messed up. So def representation, and we're overriding this so that now it's rather than a rectangle, it's a square. Okay. And this is a form of polymorphism because you have the same function representation called for rectangle and square, but they do different things because the square has a different implementation of the representation. And now you can kind of gain insight into why people like polymorphism. What you've saved yourself from doing is you've saved yourself from writing an if-then command. See, for a rectangle, if you wanted to implement for a generic case, what you have to do is if it's a rectangle, you put rectangle. If it's a square class, you put square. But it didn't need this if-then thing because already in the beginning, it was instantiated as a child class of the superclass rectangle. Right? So now, if you do S1 as square of 6 and then ask what S1 is, oh, sorry, still something wrong. Sorry, I did the wrong one. Sorry, it's 3. Which? Okay, sorry about that. I pasted in the wrong wrong one. This shouldn't have the self in there. Okay. All right. So that one mistake is just punishing me over and over again. Okay. So now you have this, and then if you do S1, now it does 6 by 6 black square without us having to have any if-then statement. So that's a demonstration of polymorphism, and this class is a demonstration of inheritance. Okay. All right. So that's the basics, very basics of OOP. Why do we like OOP? OOP has several things. It can do encapsulation. It can do abstraction. It can do polymorphism, and it can do the inheritance. All of these are desired things for making big projects. So really, you can't think of making big projects without making use of OOP or some variation of it. Okay, however, although I'm not making big projects, I do like to use classes for a different reason. And I think the standard courses on OOP miss this. The reason I like OOP a lot is because it has something called the method chaining. Okay, so to demonstrate this, let's make a new kind of class. So we'll to class car. Okay, and then we're going to define init function, and we'll make this as a function that will take, let me see, we want make, model, year, paint, tires, transmission. Okay. All right, so it's a little bit messed up. Let me make it longer. Okay. All right, so we have make, model, year, paint, tires, transmission, and we'll just store everything in the self. So self.make will be make, self.model will be model, self.year will be year, self.paint would equal to paint, self.tires equals to tires, self.transmission equals to transmission. This is really on the fly coding, so sorry if my database doesn't make sense. Actual database, if you're making such a thing and you're a car dealer, you would put a lot more things in there. But what I was really thinking about as paint and tires and transmission, let's just say these either say like very old, old, and new. Okay. Tires very old, old and new, and then transmission bad, okay, and new. So just let's think about those kind of data there, and let's say define paint self. So if you paint the car, then what will happen is the self.paint will now be made new. Okay. And if we paint if we change tires, underscore tires, self, the self.tire would be new. Okay. And then define change transmission of self. It'll be self.transmission equals to new. All right, so let's say we implemented the class like this, and then C1, the new car is Honda Accord 2021. Paint is old, tires are old, or let's say tires are worn, transmission is bad. Okay. So if you are a car dealer and you have to do some operations on this car, you would do C1.paint, give it new paint, right? Oh, sorry. Oh, sorry. The problem is we already made the paint. C1.paint would already be this one. So new paint. Sorry, new paint. Okay. There's a collision in the names. Okay, so. Yeah, that's why when programs get bigger, naming becomes a big issue. So let's go up and instantiate this again. Right? So we instantiate, and then you do C1.new paint, and then C1.change tires. And if you do all this, then you can see that C1 paint would now be new, C1.tires will now be worn. No. Why is it worn? I did the change tires. Self.tire new. Oh, tires new, sorry. Tires new. Okay. Yeah, but you get the point, right? But the problem with this implementation is that you have to do one by one, and oftentimes the manager will say, "Well, get this car a new paint and change tires and change transmission," right? So what you want to do is you want to do all of that one by one after it. So what you want to do is, like, if you had the C1 as this, we really want to say C1.new paint, and then right after calling that, apply change tires. We want to do this. But if we do that, it's going to give you an error, because once you change the paint, this function doesn't return anything. So because it doesn't return anything, you can't apply anything to it. So what I do is, to each of these new methods, you want to do return self, which is the object itself. So the object itself gets returned, return self, return self. So all of these now have return self. And let's instantiate it again. So I just put return self on all of the methods, and we instantiate this. And now let's try C1 new paint, and then apply change tires, and then change transmission. And this will work because C1, let's look at the transmission. Maybe it could have been better if I had changed the representation. Yeah, now the C1's transmission is new. And what happened is, once it painted the car new, it returned itself so that you can apply more things to it. Okay? Does that make sense? Yeah. You've made the methods to return itself. So C1 new paint is going to return the C1 object again with the new paint. and then to that new object you can apply the change.tires because this is an object, it has a method, so you can chain this. And this becomes a lot more easier when you do it in real life. So let me show you an example of what I do. So I have this Python codes that if you execute, it looks at all the like pass rates and fail rates and all these things. And I'm taking this from our banner. So banner has like what grades each student had. And as a math curriculum supervisor, I have to figure out whether changes made to this class was effective, or the new recitation class that we installated, we started taking effect, or all these things. So I have to run these. And if you look at the code, let me make the code bigger. I can't run the code because of some security issues. I'm recording this, but here's an example. So I'm looking at all those students that are in the fall semester, and the year is changing, right? And then once you select them, now I'm selecting the ones with the course that took Math 101, who is also in the recitation, and all these things, okay? So by doing these operator chaining, I don't have to think about like how to get that specific cohort of people from this big database. And if you look at how I made this class, so class students, and what it does is it returns itself, or not itself, but new instantiation of the students, where it executes some pandas command. But the thing is, the pandas commands are really long, and trying to remember all these is kind of time consuming. I have to go back to the manual and do this all the time. So if I had to use the pandas default commands to achieve the same thing, then this operator chaining will be really, really long. It'll be hard to read in humans. But because I'm using operator chaining, even just by looking at the code, I can easily see what it's doing. So this operator chaining methods, I think, is a very good way of doing coding. Now, it does waste a lot of memory, so depending on the circumstances, maybe you're trying to write an app that really has to conserve memory. In those cases, this is not a good idea. But if your database is small and you just want to get things done and you want the code to look clean, this operator chaining is a very good thing. So I would like to add this as like the fifth one. If you implement the class well, then your methods can have operator chaining. Okay? And that operator chaining makes things easier. Okay? So what did we learn about OOP? Encapsulation, abstraction, polymorphism, inheritance, and additionally, so those are the usual four. Additionally, it allows us to do not operator chaining, method chaining. We can do method chaining for classes. That's a pretty convenient thing to do. All right, so hopefully this wasn't too theoretical, but it's very important. That's why I had to cover it. Now, we've been having this Python class to make one game every day, and then that kind of made the things fun, right? So I want to kind of kick off that again. This time I want to have a graphical game. And you know, with this, in this age of ChatGPT and cloud, it's really easy to make these games. So what I did was this morning, I just came in and asked Cloud AI. Okay, so this is something that Cloud AI made for me. Let's run it. Let me show you. It's a shooting game. Oh, yeah. I get carried away playing it. Every time you hit the balls, then the number of balls increase. All right. So I want to try making this. It's rather long, so it will take us maybe, if we start today, we might be able to finish by Thursday. Okay. Yeah. But it looks fun, right? Okay. So let's start writing this code together. And to do this, we first have to install a Python library called Pygame. Now, that requires you to go to the console and then do some commands, but the easiest way to install Pygame is right here on the right side console. You can do exclamation mark. That means you're now running system commands, okay? Exclamation mark, and then you do pip space install Pygame. If you enter this, it's going to take, yeah, so for me it's already installed, so it's going to say this, but for you it's going to be hung for a while because it's searching for that package, downloading it, and then installing it in your computer, or so you'll have to wait a little bit. How many of you already got it done? Oh, some of you already got it done. Okay. Yeah. Some are still waiting.
It says command not found. So just looking for it.
It should. Oh, it's in your own computer. Is it a Mac? Oh, okay. So for Mac, it might be pip3. Yeah. pip3 install Pygame. Yes.
My kernel like completely disappeared.
3 install Pygame. Okay. So if you install the Pygame, now you can import Pygame and do things. Right. So let's try to not do this, but let's try to start a new thing. And let's see what we can do. Import Pygame. And because we will have to refer to the Pygame many times, let's make it as a name. So make a alternate name for it. So import Pygame as PG. We're going to do that. And then for any Pygame, you have to do pg.init. Pygame.init should be done. Why? Oh, yeah, okay. For a moment, okay. And then we're going to have width, comma, height equals to 800, comma, 600. Okay. Why am I putting everything in caps? Remember? Constants, right? Yeah. So in Python, if you want to define a constant, you should always try to put all caps. That's the convention. Okay, and then we have to do screen. We have to instantiate a new screen object, and it's pg.display.set mode with width and height. Okay, so that gets the screen ready, and then let's define some colors. So we have black equals to 0, 0, 0. This parenthesis means that it's a tuple. It's a tuple of numbers. You could also use instead of tuple, you can use the rectangular ones. But since we're defining a constant, right? And tuples are not mutable, it's immutable. So it's good to use tuples if you're defining constants. Now, why do I say black is 0, 0, 0? What do these numbers mean? Do you have a guess? Yeah? Yes, exactly. So it's the RGB value. So if RGB values are all 0, that's black. Okay? And then if you want white, that's 255, 255, 255. Those are the maximum RGB values. So you're making everything white. Okay? And then for red, you just want the red to be turned on. And therefore, if you want RGB blue ones, then you would put 0, 0 to 55. Okay. All right, so what can we do with this? Well, we can use the screen. We can use the screen to be black. So if I do screen.fill black, okay, and then pg.display flip. Let's run this much. Size must be 2 numbers. Oh, sorry. There should be a parenthesis around it. I didn't see that. So you have to set the size as something comma something. Okay. So this is passed as one argument into the set mode function, right? Okay, let's run it again. Okay. Yay, we achieved something. We got a black screen, right? Yes.
I got no module named Pygame.
If you don't have the Pygame, then okay. If you get that message, how many of you else got no module named Pygame? Okay, so in that case, what you want to do is you have to go to console, and you have to do restart kernel. The reason is sometimes when you install new packages, the current kernel that's running does not know that it has this new kernel installed. So you want to go to consoles and restart kernel and then run it again. It should work. How many of you now has it working? If this shows that, then what you have to do is you have to go down and look at this window. It opens a separate window, okay? So you can, okay. So we can get rid of it. Okay, so now another thing that you observe here is that it's restarting kernel. Why did that happen? It's because when I displayed something, the Pygame has the window open and it doesn't know what to do afterwards. It simply just has it out there. And when you try to close the window, the system, operating system, tells Pygame, hey, you have to shut up, okay? You have to shut down. And the Pygame says, I don't know how to shut down, okay? Then the program, the operating system says, well, too bad, you'll have to shut down. And it just destroys the entire program that's running it, which is the Python itself. So it destroyed the kernel, Python kernel that's running the Pygame. And this is not a desirable situation. So what you have to do is in any of these situations, you have to import, when you use Pygame, you have to import two things. One is import time, okay, and then import sys. Okay? And at the end, what you want to do is you want to do two things. You want to do time.sleep for, say, a few seconds, maybe 20 seconds. That's too long. Let's say 5 seconds. Okay. And then you want to do pygame, pg.quit. So always you have to tell Pygame to quit, and then you want to do sys.exit. And that completely quits the Pygame. Now let's run it. If you click on this new window, you'll see that, yeah, it just 5 seconds passed. Okay, so now we have this, and then it disappears after 5 seconds. Good. Okay. So that's not too interesting. So let's just do one more thing for today and call it a day. So what we're going to do is we're going to do pg.draw.circle, draw a circle, screen, okay, and then let's put a red one, and then red one, and then we're going to put it at the center. See, oh, one thing that you have to know is that for Pygame, the top left coordinate is 0. Okay, so it has 0, 0, and therefore, if you want the exactly at the center, then you need 400 to 300. So you want to put 400, comma 300 as the location, right? And then you have to provide a radius. Let's put a radius of, say, 20. So let's do this. So what's going to happen if we run it? Oh, sorry. What happened was I didn't display it. So display flip should be after drawing. Okay, so you do this. Now you have a red circle. Okay, well, it's a bit, let's do one more thing, okay? Now let's try to move this circle. How do you do it? Well, what we're going to do is we're going to do filling everything with a black screen and drawing a circle on a loop. So I'm going to surround it with a loop. So for I in range, say 100 loops, okay? And then we're going to put everything inside the loop, so I need to put tabs, okay? And what we are going to do is I'm going to make the x coordinate to start from, say, 300, and then we are going to make the circle move by 2 pixels at a time. So we're going to do I times 2 pixels. So that will make the circle move 2 pixels at a time. But you know, if I go to the next screen too fast, then you're not going to see anything, right? So we're going to have to do time.sleep. Now you could do time.sleep with 0.1 second, or you can also do time.wait, which goes with milliseconds. So let's not use time.wait.
It says for mine, it says Pygame has no attribute circle. Let's go draw.
Yeah, pg.draw.circle. Yeah. Okay, so now let's run it. Let's see what happens. Oh, sorry. Keep doing the wrong thing. I don't know if this is going to help, but let's just do one more. pg.display set underscore caption space false. It's the name of a movie before, right? Who watched it? Oh, okay, now it works. Somehow I need to set the caption, and now it works. It's moving very slowly because we made the time.sleep too large. So maybe what you need to do is to make the time.sleep to be 0.05. Now it's going to do double time. Okay, so that's all for today. Thank you.